Hey all, welcome back to my channel. If you are new to my channel, consider subscribing my channel and hit on the notification bell. Okay, and also follow me on LinkedIn. Today is going to be a interesting topic. That is, I, you, and we together are going to write a program in gate level model. Okay, so the concept that we have taken today is decoder because I am also bored with examples on full ladder and muxes and all. So let us write something new today. So we are going to take a decoder example. So before writing a code in gate level modeling, first let us know some few basics of decoder. So as you already know, the decoder is a combinational logic circuit. It is having n input signal lines and n to power n output lines. Okay, right? So the basic decoder that we are taking today is 2 by 4 decoder. So it is having two input lines and four output lines, and also we are taking a one more input like enable. Okay, so if you see here, this is the truth table of my decoder. Okay, right? So this is my 2 by 4 decoder. I have taken like two inputs a comma b and one more enable. Okay, and then it is having four outputs like y0, y1, y2 and y3. Fine. So this is the logic diagram for my decoder. Okay, if you see here, I have taken like this is the logic diagram for my decoder. Now by using this I am going to write a code. Got it? So if you see here, before entering into the code, let us see like we are having, what are we having here, like four AND gates, A1, A2, A3, whatever names it may be. Okay, four AND gates and three inverters like I1, I2 and I3. And also you are having like basic net connections like EN, A, anything. Okay, you are having like three wire connections here. Okay, like extra connections. Apart from these three, you don't have any connections, like these three are all connected to these connections only, right? So this is all. Now let us write our code. Okay. First, what we have to do is open your Chrome and then log into, okay, EDA playground. Okay, so as soon as you enter into the EDA playground, okay, like it will ask you register. Since I have already registered, it won't be asking out. Let me do this. Okay, so okay, so as soon as you register, it will be asking you like what is the how to log in into the EDA playground, right? So then after logging in by using Gmail account, you can log in by using a Gmail account, and then here this is my EDA playground. In this EDA playground, what you have to do is first you go to this tools and simulators. Okay. Apart from this, you don't need to take anything. In this tools and simulator, you can choose any options like Aldec, Rivera Pro, or Cadence, anything. But mostly for basics also, it will be better if you use Aldec Rivera Pro. Okay, is the simulator. That means simulator. I think you already know. Like it is used to run your program. Okay, and now what you have to do, this is my design and this is my test bench. Like you will be having two screens. One is to write your design code, nothing but RTL code. The second one is to write your test bench code. Okay, so now if you see here, let us write the code like module, okay, space, right, decoder 24 underscore gate, any name you can write, like any name, just it is decoder 2 by 4 gate by using gate level modeling. That is why I have named it like this. Okay, and within the braces, what are the inputs that you have taken? If you see here, A, B, enable, the same thing here, A, B, enable. These three are inputs. And Y is the output. The same thing. Now you will be mentioning the ports. Like A, B and enable are input ports. And coming to output port here, you are having four outputs. So that is why instead of taking like Y0, Y1, Y2, Y3, what I have done here is I have just taken one variable Y and I have given the width of that variable like 3 down to 0. Okay, you can either do like this or you can just mention it like Y0 comma Y1 comma Y2 comma Y3. It's your wish. Fine. Okay, so this is how. Next, if you see here in the location, you are having like three wire locations, NA, NB, and this is also you can name it. Like I have named here like three things. Like see NA, NB, ENB. Okay, enable. ENB is enable wire. NA is this first one, and the NB is second one. Now let us write the code here. Now if you see the thing, what am I having? First I will be writing my code for NOT gates. So for this is a single gate primitive. So you will be having first you should mention output then input. So that is why see here first output NA then input A. First output NB then input B. In the same way first output ENB and then input EN. Okay, and then what am I having four AND gates. For this first AND gate, what is my output? Why not? Okay, if you see here, and I'm having like three inputs. What are the inputs here? See, why not? Nothing but y of 0. And now if you see the inputs here, the first input is, if you see here, NA, okay, and then NB, and then if you see here, ENB. So see NA, NB, EN. Okay. Similarly for all these four gates for Y1. If you see here NA, okay, B, and then EN. Sorry, ENB. See ENB, NA, and B. Similarly for Y2, Y3, and then N module. Okay. So this is how you will be writing your gate level modeling code on decoder. Now for this same thing, if I want to write a test bench, how am I going to do it? So see module test bench. Okay, module space test bench semicolon, and then here E and A and B are inputs, so they will be used named as ridge. Okay, ridge A B E N, and since it is output, so they are wire. Okay, and now instantiation. So if you see this, this is my gate level. This is my gate name, and with DUT I'm instantiating it. So how am I giving it? By order E N A B Y. Okay, here you don't need to mention the size. Okay, you just need to mention what are the ports, because you are just tying them. That's it, you are mapping them. You don't need to write like in a blender. But here what is important is whatever you are taking, the if you this is a scalar, then this should also be a scalar. If this is vector, then this should also be vector. Okay, just remember it. And then initial begin, you will be passing the values. Like see here, at first enable is 1 and A is 1. A is 1 to be X and X. Okay, and then after 5 time units it is 0. Enable is 0, A is 0, B is 0. After some time enable is 0, A is 0, B is 1. And then 0 1 0 0 1 1. Okay, 0 0 0 1 1 0 1 1. This is my basic thing, and then finally I have done the finish. Since I have given it in within begin, so I have to end it. Now I am using dollar $monitor. Okay, in order to display all my values. See, enable, I want to display everything in binary format. So enable equal to percentage b, a equal to percentage b equal to percentage b, y equal to percentage b. Okay, so now after doing all this, what you will do is you will save it. Okay, and then after saving, run it. Now if you see at when enable is 1, what is it? A equal to x, b equal to x. That means I didn't give any value. So it is the y is, that means all are high. Now if you see at 0, enable equal to 0, what are the values that I have given? A is 0 and B is 0. So when A and B both are 0, what is the thing that should be active? See, when A and B are zeros, if you see here, what are the values? Y2, Y1, Y3, Y2, Y1 are ones and Y0 is 0. So now see, 1, 1, 1, 0. Okay. When it is 0, 1, 1, 1, 0, 1. See, when it is 0, 1, 1, 1, 0, 1. 1, 0, 1, 0, 1, 1. Right? Is it like this? Yeah. Fine. So this is how basically your output will be executed. Okay. Just as simple. Any program in gate level is really simple. What you need to know in order to write your gate level programming is the truth table and then the structure. The structure is very important when it comes to gate level modeling. Apart from everything, you just need to know the structure. Okay, you don't need to know anything. You can blindly follow. When you are having a structure, you can blindly write the gate level coding without any doubt. Okay, clear? So that is all for today. In the next class, we will be going to see about gate delays and all. Okay, thank you.